Welcome to Building Content Knowledge in Mathematics. My name is James and welcome to episode 3 where we're looking at financial contexts. The learning intention today is to explore a learning trajectory for teaching financial mathematics, to identify effective activities you could use to teach each stage of learning, and to strengthen teachers' mathematical content knowledge in financial mathematics. So a learning trajectory that I like to use, that I brought together from a few different pieces of information, is as follows. We want to start with recognizing, comparing and ordering money, and then adding money together, calculating change, and then going a bit broader and thinking about planning and decision making around financial planning. So if you want to stop the video right now, quickly pause it and have a look at the different stages that I've outlined and the different conceptual focuses and the key understandings and strategies. Do that and then we'll follow and progress along. Okay, hopefully you had a bit of time to have a look at the learning trajectory that I've outlined for the teaching of financial mathematics. The first stage is looking at recognizing. What does it mean to recognize? To recognize is to see and to know. As we move deeper into a predominantly cashless society, it's becoming increasingly important to teach Australian money with depth and purpose. When we tap a card, we don't consciously think about value and worth. The physical exchange of money for goods is invisible. However, when children engage with physical money, students can see and feel this transaction of worth taking place. This tangible experience helps students to grasp that every coin and note represents something of measurable value. So it's important that we have those hands-on activities so we can identify, hey, things cost money. It's not just, we don't just tap something that's invisible and then all of a sudden we get it. There's an exchange going on in terms of value. So how do we build this idea of recognition when it comes to understanding money? Well, we could do sorting activities, placing mixed coins and notes in the center of a table. Students can sort them into jars labeled 5 cents, 10 cents, 20 cents, and discuss the attributes such as the color, the size, and the worth. You might use mini whiteboards, show a coin or describe its attributes and have students write down the denomination on the whiteboard and then what I like to call chin it. So to check for responses, that's immediate feedback and you can identify who knows different attributes of coins and identifies immediately and recognizes those coins. You could do a see and say. A see and say is to let out small collections of coins, lay out small collections of coins, and students have to identify how many. I saw 20 cents. I saw one that was a 10-cent coin. There's also money dice you can get where students can roll the dice and then a denomination comes up and they have to say it. And then identifying attributes, so using a modified Freya model to analyse the attributes of money, including who appears on the coin, animals, flora, and the history behind the denomination, its colour, and any personal connections a student might have to it. Just a little caveat, I personally am not a fan of coin rubbings as I feel that maths turns into an art lesson, and what we want to be doing when we're in the mathematics classroom is to be making sure that students are thinking mathematically. I feel like whenever I've seen teachers engage with coin rubbings, that it becomes more of an art task and the math starts to be, lost within the lesson. That's just my personal opinion. Take it as you see fit. All right, so once we recognise, then we can compare objects. And with this, we facilitate the proficiency of reasoning. So something that we can do to compare objects, or coins I should say, is looking at true and false statements. They help iron out misconceptions. So 50 cents is larger than $2, so it's worth more. That's a misconception. When we talk about value, we mean that a coin weighs more than another. That's another misconception. We might do more or less activities. So students roll 2 money dice and yell out more or less. How much more is one coin than another? How much less is one coin than another? Ask students to write statements. You could say 50 cents is worth more than 20 cents. 5 cents is the smallest and worth the least. $1 is equal to 100 cents. Or you could use coin clues or coin riddles that Dr. Paul Swan has. There's an example of the one to the left-hand side. What coin am I? I'm a silver coin. I'm worth more than 5 cents. I am less than 50 cents. And I'm about the same size as a gold coin. So if we use those clues, students can distill that we're talking about a 20-cent piece. Or are we talking about a 10-cent piece? I think we're talking about a 10-cent piece here because I am about the same size as a gold coin. $1 is roughly the same size as 10 cents. Then after we recognize order, we compare. So what I like to do is I like to put a number line or an open number line on the board, and I like students to order coins from worth least to worth most. We start layering this idea of 100 cents being $1 and showing the different notes. So I like to order coins and notes so students can see the value of money. And then we can also identify misconceptions. So for example, even though 50 cents is the largest, it's not worth more than a $2 coin. $2 is worth 100 cents. So the first protocol when we're looking at adding small collections less than or equal to $1, we've got to be thinking about the very first protocol is adding 2 coins. So whenever I've done this with students, I always do the count on from largest strategy. So we've got 20 cents and 5 cents. So I might say, all right, we're going to count on from largest. We're going to start at 20 and we're going to count on 5 more. We've got 25 cents. So adding 2 coins together is the first protocol. Then I've noticed when I'm teaching students in, say for example, the junior years, your grade 1s, your grade 2s, that third coin becomes a little bit more cognitively challenging. Students have to decipher which coin is worth more and then count on from largest. So if we're calculating the 35 cents in front of us, we can see that we've got 20 cents. Oh, then we add 10 to make 30 cents, and then 5 cents more is 35 cents. So using that count on from largest strategy, our additive strategy. Then lastly, when we're looking at calculating change, calculating totals, we're grouping coins. So something I like to do is I like to push into that multiplicative thinking as well if we can. Oh, we've got 4 20-cent pieces. 4 times 2 is 80 cents. And then we've got 10 more and then 5 more. So what we're trying to do here is we're grouping coins together and then pushing students into maybe that idea of multiplicative thinking. So just to recap, start off with 2 coins, then add in that third coin, and then look to group coins based on their denomination. All right, then something I also like to do is when we're looking at adding coins is doing those open-ended tasks. How many ways can you make $1? So that so you can show students that $1 can be made in many different ways. It's not just 5 20-cent pieces. So all these different ways that we can calculate $1. So using those open-ended tasks are really good because we can see all the different ways that we can make a certain denomination. All right, so adding larger collections greater than $1. Also, we've got to be talking about the decimal point. Okay, discussing the decimal point, everything to the right represents cents, everything to the left represents whole dollars. So if we start layering in this idea of gold coins, $1 equals 100 cents, $2 equals 200 cents. So we're once again using that count on from largest strategy, count my gold coins, and then add what's left. From there, we also I like to group coins to make $1. So if we've got denominations or we got coins over $1, I like to make groups of $1. Make groups of $1 and then add what's left. So we start off, we calculate our gold coins, then we calculate how many piles of 100 cents we have, and then we add what's left. So a big thing when it comes to recognizing, comparing, and ordering money is rehearsing and reasoning. Something I also do with my students is a WODB, which one doesn't belong. The great thing about which one doesn't belong is a few things. Firstly, you're comparing money. You're comparing, I'm comparing the total in the yellow box with the blue box. I'm comparing the yellow box with the red box. And then what I'm also doing is I'm adding money together, but I'm also comparing it. So adding and comparing. There's really rich to do a WODB, especially when you want students to rehearse and you want them to practice. Practice has become this dirty word in mathematics, probably like in the last 10 years, but now it's actually people are starting to realize, hey, we actually need a lot of practice. To push things into the long-term memory, we need to rehearse, we need to practice, we need constant exposure. And with a society when we're looking at a cashless society where we're always tapping our card, this becomes extremely important in education settings. Okay, so let's talk about some misconceptions before we move on. So $2.50, the dollar sign at the front. Some students will write 45 cents and have a really big C next to it, making sure that we're writing the C nice and small next to the 45 cents. Then also some students will do two lines through the S to represent dollars, which is an American standard. Some students also do the dollars and the cents. They have the dollar sign and the cent sign. So making sure that students understand that, hey, when we go over, when we're at 100 cents, we actually use the dollar sign because it's $1. So bridging on from that, moving on to notes, what I like to do is I like to teach a strategy of adding notes, adding the gold coins, grouping dollar 100-cent denominations, and then adding what's left. So that's my trajectory that I teach students how to calculate coins and notes. All right, so now we're going to move into calculating change. I've found personally that calculating change within a dollar is a nice place to start, and then bridging through a dollar, and then going within $2, and then bridging back through $2. So constantly going from that, okay, within the amount, and then bridging back through the amount. So that's a really nice way to teach students how to calculate change. All right, so something I also like to do, I'm big into visible thinking routines. The first one that I showed you was a WODB. This second one is what's the difference? So you have two piles here, you have two denominations. For example, on the left-hand side, we have 80 cents and $1. What's the difference? It's 20 cents. So we're talking about, all right, we have to calculate the total amount and then compare. We're calculating and comparing. So it's a nice way for that rapid rehearsal of calculating change. Also, you get that reasoning involved as well. So we have, on the right-hand side, we have $2.50 and then $1.25. We can say that $1.25 is half of $2.50. So you're starting to build that reasoning in. So what's the difference? Really nice reasoning tool, and also getting students to calculate money. Okay, so calculating change again. Once again, I like to use models. In the Victorian Curriculum 2.0, we see part whole models becoming ever present. So something I like to do is use that part whole model to calculate change. So I've got $5, take away $3.85, what is left? So you're using that part whole. And it's a really nice way to model how to calculate change. Another thing I like to do is use the shopkeeper method on a number line. Using open number lines are so underappreciated. So if we're calculating change, okay, I go to the shops, I buy something for $3.40, but I pay with a $5 note. How much change do I receive? Using those progressive jumps on that open number line really harnesses that thinking, really helps students to, in that concrete pictorial abstract, make sure that they're looking at that pictorial. All right, now we're moving on. We're moving on to budgeting. Okay, so we've gone from this process of recognizing, comparing, and ordering, then to adding coins, then we're looking at coins and notes, and then we're calculating change. Now we're looking at that next process. We're looking at that senior level of curriculum, a grade 5, 6 level, creating a financial plan or budget. Financial plan or budget is a way to organize money to make sure there's enough for the things we need and maybe some of the things we want. So what I like to do is I'd like to take the students through this process. Okay, identify how much money do I have? All right, you've got $200 and we're going to do a party budget. All right, what are our expenses? What do we need to be successful with a party? What are our needs and what are our wants? We're going to categorize those two. Then we might, if you're going a little bit further, you might set savings goals. So I like to talk about savings. All right, if you make X amount of dollars, how long will it take you to reach the $200 you want? So say, for example, they're doing chores at home and they get paid $5. Over what time course do I need to spend doing those chores for me to hit my budget requirements? Then I also like to go about making a balanced income and expenses through making a plan. So making a plan of what what's our saving goal, what's the money that we're working with, and then work on developing that budget. And I might use something like Excel with my grade 5 6 students to really try to map out and do a nice layout of what a budget looks like. It also teaches students about needs and wants. Do we really need certain things? And and talk about living beyond your means and making sure that we're very conscious of our money, because something that we don't do enough of is talk about budgeting with students and making sure that we have enough money. We have enough money so that we can buy the things that we need, but also we can budget for what's left over so we can get what we want as well. I think that's very important to discuss. So classroom ideas: start small, budget with $5 and $10, discuss needs and wants, tell students that they have a budget of $200 to plan the food for a party, get students to explore, say for example, Coles online, write a budget, get real world and connect it to home. Give students a budget with a bunch of errors. That's a really nice one I've done before. Provide students with a budget, throw in a few different errors. Hey, where did John go wrong with this budget? How could he improve this budget? What are his next steps? You could show a spreadsheet with missing items where students have to identify the missing items on the list. Once again, talking about digital tools. Use those digital tools like Excel to structure the work. All right, now we're going to move on to percentage of versus percentage off. Percentage of, when we say percentage of, we're finding a portion or part of a total amount. It tells us how much something is worth before applying any discount. So for example, let's go into it. 25% of $100 is $25. When we think of, we're trying to find a part of a total. The difference between of and off, when we're looking at the percentage off, we're talking about a discount or a reduction in price. First, you need to find the percentage of the original amount and then subtract it from the total. So for example, 25% off $100, we're looking at, all right, we've got to find 25% of $100 and then we've got to take away from the total. So $100 take away $25 is $75. When we think of the word off, we've got to be thinking about subtracting the part. So I'm going to go into that next. So how do I go about modeling it? So here's a number line looking at percentage of using a number line. So $10, we have 100%. 50%, we identify half. 50% is half, so it's $5. 25%, half of a half. Half of a half is a quarter, so $5. Half of $5 is $2.50. I also like to put into my number line what is 5% and what is 10%. Because generally, if you have 50%, 5%, and 10%, you can generally work out a percentage of from those pieces of information. So for example, if 100% is $10, 10% must be $1. Therefore, 10% of $10 is $1. Moving on from there, once students really get fluent using a number line, they can do the mental calculation themselves. So I've broken this up here. $12, 10% of $12 is $1.20. 5% is 60 cents. And then if we look at 50% of $12, we have $6. So you're just identifying the parts. So we're moving from that real scaffolding using a number line to moving on to looking at the parts. And then also, I like to teach other strategies as well. So when we look at percentage of, we're talking about multiplication. So we can use the commuting strategy. So instead of saying 62% of $50, we could just say 50% of 62. We could just halve 62 and we know it's 31. So it's $31 because we're using those underlying multiplicative strategies of, say, commuting. All right, so now we're looking at percentage off. So percentage off is a percentage discount. We're looking at subtracting from the total. So if we know the percentage of, we can calculate the percentage off. So let's have a look at this. A shirt costs $12, but is 10% off. How much does the shirt cost? Step one, find percentage of. So if we have $12, 10% of $12 is $1.20. Step two, what we do is we know that the total is $12 and we know 10% of $12 is $1.20. So we subtract that amount and find it's $8.80. So it's very important developmentally that we talk about percentage of before we talk about percentage off. And then we've got percentage more. Sorry, I'll put in percentage discount there. I don't know why I put that there. Percentage more, we're talking about addition. All right, so disregard what I've got there with percentage discount. We're looking at addition. We're looking at percentage more. We're adding more. A shirt is 10% more in store A than in store B. If the shirt is $10 in store A, how much is it in store B? So what we do is we once again we find the percentage of, find 10% of $10, it's $1, and then we add that percentage onto the total. So for example, $10 plus $1 is $11. Then we're looking at best buys, we're looking at ratio and rate, okay? So when we're comparing, after I do budgeting and then we talk about, so we start with budgeting and then I move on to discounts or percentages of and percentage off. After budgeting and then discounts, so percentage of and percentage off, I then move into calculating best buys using ratio and rate. So at supermarket A, you can buy 8 cans of soup for $5.20. You can buy the same kind of soup at another supermarket B, for $3.10 for 5 cans, which is the better deal. When we're looking at rate, we're just essentially saying, all right, we want to get down to the unit price. What is the unit price at both stores? At the top one, we can see the unit price is 65 cents per can. At the bottom store, we can see that it's 62 cents per can. Now, while it's nice to be talking about best buys with ratio and rate, it's important to contextualize ratio and rate. So we've got to be thinking about actually decisions. Will the person buying the soup need more than 5 cans? Will the person buying the soup use the cans in the future? What is the use-by date or shelf life of these cans? Do they see value in the item and therefore disregard the price? I know some people, because they make a certain amount of money, can just go in and not worry about best buys. And they're not worrying about being savvy. But for a lot of Australian families, you are looking to be savvy at the supermarket and looking at best buys. And thankfully, I don't know how long it's been happening, but at Coles and at Woolies, you can actually see the unit price, which makes it a lot easier to compare products. But then also you're talking about quality of products. Some products have less quality than others because they might be made overseas, or they might be made with a worse product. I'm not sure. Personal income is 3 cents a big factor for some people when comparing between 62 cents and 65 cents. So something to think about when you're talking about ratio and rate is really making sure you're contextualizing. We've got to contextualize, because it's all good to say, hey, one shop has it for 65, has a can of soup for 65 cents and another one has it for 62 cents. But in the grand scheme of things, we've got to think about all these decisions external to the ratio and rate. And that's it for today. Thanks for joining me. I'm hoping to do these more frequently, and hopefully you're building some content knowledge in mathematics, and I look forward to discussing this with you online. And I hope you have a lovely day, and thanks for joining me.